Hydro's unique patented can-float system enables flood-resilient residential and commercial developments within the floodplain. In its most basic form, the first stage is to excavate a void marginally larger than the proposed building. The void is lined with either a combination of sheet piling and concrete or else simply concrete. A precast waterproof concrete pontoon is lowered in and guide piles attached to titanium rollers are put in place. A gap of up to 500 mm is left between the walls of the void and the pontoon itself to allow for floodwater ingress. The gap is bridged by a cantilevered concrete skirt. As the pontoon rises, it is guided vertically and laterally through the roller and pile system. The pontoon sits upon risers to allow the passage of water beneath. In a flood event, water fills the void. The pontoon will reach a point of buoyancy and begin to gradually rise up with the water. An additional benefit of floodwater being contained within the void is that it naturally reduces the amount of water passing onto neighbouring properties. As the floodwaters recede, the pontoon structure gradually and safely returns to its original position. Any excess water is removed from the void using a built-in pumping system. In order to prevent debris entering the void, a flexible mesh system is incorporated which spans the gap between the pontoon and wall of the void. Dependent upon design requirements, the pontoons can be used as fully habitable basements, with natural light brought in through the use of light wells or high-level windows. A single concrete transfer slab is placed across the top of the pontoon, and the superstructure is then built upon that. There are no limitations to the size or design, and within reason, there are few limitations to the number of stories that can be created. In order to minimise the weight of the superstructure, a timber-framed modular system is normally used. The guide pile system can be concealed in a number of ways, such as, in this instance, within a chimney breast. Whilst the house modelled here is quite rudimentary, there are no restrictions upon the aesthetic design, and the buildings can range from the very traditional to the highly contemporary. Additionally, the footprint of the floating pontoon can be extended beyond that of the building to provide space for garages, terraces or gardens. In all cases, the houses are designed to be highly sustainable, with, for example, grey water recycling systems, photovoltaics and high levels of insulation. As the floodwaters build up, the void fills and the complete building becomes buoyant, rising gently with the water. The original access to the building takes the form of an articulated pathway. Services remain connected to the building using a system of flexible knuckle joints, enabling connections to remain in place and move with the building. As long as services in the area are maintained, the house will remain fully functional, and will of course have the backup of the photovoltaic and grey water systems, thus creating a self-sufficient haven during the flood event. The buildings can be mortgaged on standard terms by most high street lenders, and despite being in the floodplain, also qualify for household insurance on standard terms. As the water recedes, the house returns slowly and safely to its original position. The flexible construction system allows near-limitless design permutations. This unique patented can-float technology provides a safe haven in a flood event, allows environmentally responsible development in areas prone to flooding, can be mortgaged on standard terms from major high street lenders, is fully insurable on standard terms despite being in the floodplain. Propreties, the solution to living with rising flood levels in the UK.